Welcome to the deep dive. Today, we're going straight to the source and looking at the specs for a single piece of hardware.
Just one. The NTI E-STHS-PRC environmental sensor.
Exactly. They call it a low-cost precision temperature humidity sensor. And our mission today is to figure out how a $250 device delivers on that promise.
Especially the precision part combined with distance. That's a really unusual combination at this price point.
Right. And you look at the specs, and you can see it measures temperature, humidity, and something else that's really critical.
Dew point.
Dew point. Why is that so important?
Well, dew point is the temperature at which air becomes saturated and condensation forms. And if you're running electronics in, say, a remote cabinet, moisture is the enemy. It's the silent killer.
So this sensor is basically your early warning system for that.
Exactly. It tells you when you're at risk of water forming on your expensive gear.
Okay, so let's get into the precision part. The numbers here are pretty impressive.
They are. The operating range is what you'd expect, 14 to about 140 degrees Fahrenheit.
But the accuracy. The temperature reading is within plus or minus 0.2 degrees Fahrenheit.
Which is just, wow, that's plus or minus 0.1 Celsius. For a mass-produced unit, that is remarkably tight, and humidity is within 1.8%.
You'd think a sensor that precise would need a lot of power or some complex setup.
Not at all. It runs on a simple 5-volt DC and only draws 20 milliamps. Super lean.
So it's easy to integrate.
Incredibly easy. And it has all the approvals you'd need for enterprise. CE, ROHS, and it's TAA compliant, so it could be used in U.S. government projects.
All right, so here's the big question for me. How do you maintain that kind of precision, that tiny 0.2 degree accuracy, when the sensor is hundreds of feet away from the main unit?
That is the core of it, really. That's the aha moment when you read the spec sheet.
The signal usually degrades, right?
It does. But this one uses a specific communication method. It's RS-485.
Okay, RS-485. And that runs over standard network cable.
Yep, CT5, CT6, the stuff that's already in the walls everywhere. And that setup allows for a cable run of up to 1,000 feet.
1,000 feet? That's over 300 meters. So why is RS-485 so good at that distance?
It's all about how it sends the signal. It uses what's called differential signaling.
So what does that mean in simple terms?
Instead of sending a signal on one wire and comparing it to ground, which is really susceptible to electrical noise.
Like from power cables or motors?
Exactly. RS-485 uses 2 wires, and the receiver just measures the difference in voltage between those 2 wires.
So any noise that hits both wires at the same time just gets ignored?
It gets canceled out. This makes the digital signal incredibly robust, so the precision reading from the sensor arrives intact, even at 1,000 feet.
That's already a huge distance, but you found that it can be pushed even further, didn't you?
Oh yeah, way further. If you pair this sensor with a specific fiber optic extender, the EFSC fiber converter,
you can put it on a fiber line.
You can. And then you can place that sensor up to 1.2 miles away from the main Envirom-UX unit.
1.2 miles. Okay, that's 2 kilometers. We are way outside the server room now.
We're in full-on critical infrastructure territory at that point.
So to recap, what we have is a low-cost, incredibly precise sensor that's been specifically engineered to send its data without any loss of integrity over these massive distances.
Right, and that really leaves you with a final thought to mull over.
Go for it.
Considering this blend of low-cost, extreme precision, and that incredible range, what kind of mission-critical systems, spread out over miles, would absolutely depend on knowing about a temperature shift of less than half a degree?
You're thinking about things like utility grids or maybe long-haul telecom networks.
Exactly. Think about how many miles of unattended fiber optic cable or how many power substations are out there. They rely on this exact mix of cheap deployment and absolutely bulletproof reliability.